So we're going to use this tool now called Plotly to generate some graphs or charts for us for our labs. You can visit the site. It's plot.ly, and you can log in or use any of these credentials: Facebook, Twitter, GitHub, or Google. And you don't even have to log in. You can just click this and go to create a chart if you want to. The downside of that is that you cannot share it or anything like that, or save them. So what we're going to do is I'm going to log in with my Google credentials, and here you can see it has gone in. I'm using a free account, so everyone should be able to do this, and I'm going to create a new chart. So here it's thinking, and here you can see a plotting space and a data entry space for your data. And here you can choose the different type of graph. So I'm going to put in some preformed data, and I'll show you this. We go here and you can see there's a series of data 1 through 8 and then something that is not a simple series. What do I have in A? I have in A time, so I'm going to rename that header and I'm going to say it's time, and this isn't done in minutes, right? This way people can know what your unit is. So that's fine. Generally when we're speaking, we have a responding variable that responds to something that changes. And here we're just waiting. So what is the responding variable? It's this. And in this case, it happens to be optical density, or OD. And so we're going to say like absorbance units or something like that, AU, and confirm. Once again, you try to be as descriptive as possible, but people should be able to tell from the type of experiment that you're doing. So notice that there's nothing on the plot yet because this data is not stated in such a way that Plotly understands. So we need to remember that X is what we change, or what can be changed, and the Y is what responds to what we're changing. And as I said before, we're looking at minutes or time. So X we're going to set to time, right? And notice this is still not correct. You see a straight line, that's because it's going time by time. And now we're going to change Y to illustrate what's responding, and that's the absorbance value, or OD units here, right? And you can see now it's not the same labels or the axes. So this is actually great. However, we want to fit this line, so we need to do an analysis. How do we do an analysis? We go over here and we click on the analysis button, and we can add an analysis or plus analysis. And what are we going to do? We're going to do a curve fitting. That means we're going to actually fit this information here. So the chart type is actually going to be based on this OD units, and we're going to choose a linear equation. You can see there are other ways to do this. Not all data is linear, but ours is mostly linear, and we're going to deal with that, right? Also, we have to pay for these, but we can do linear. And as we know, a linear equation is defined by the basic equation that y is equal to m times x plus b, where m is the slope and b is the y-intercept, right? So that seems fine. So we're going to press run. And there it is. This is our data, and it's essentially a line that illustrates the best fit of all these points. It's kind of like the averaging average distance from each of these points to generate this. And you can see that it's being pulled away from these points because this one is not in the linear area like the rest of them. But that's fine. So what can we do? We can look at some details of this line here with the R-square value, which tells us that this is a 94% good fit. So that's decent. And here's M, which is the slope, and B, which is the y-intercept, right? So what is really useful is to actually put this on here so we can add results as an annotation. Click this box, and there it shows up. And we can pull this off to the side to make it more readable, right? At this time, we still don't have a perfect graph yet because we need to give it a title. And so we're going to click on this to enter the title, and we're going to say change in absorbance over time. And that's relatively descriptive of what we're doing here. Of course, we can be more descriptive if we knew what the experiment was. And now we can understand that y is equal to 0.088 x plus 0.065. This is where this line crosses this axis here. and this is the slope. And what we can now do is use this line or this linear equation to make predictions of unknown things. So if we had an unknown thing, we might actually have this, and we'll be able to tell at what time point it will occur. It allows us to predict into the future, as well as understand at what point in this series of time these events occurred. So that's it, and I hope that everyone can do this very relatively easy. And there's one last thing that we can do to share it with other people, like your professor, is we can actually go save this, right? And it'll tell you of the things. Right now, it's private and whatever. So you can save it, and some things require you to upgrade, but you can save it as some sort of image file and send it off, or you can share it. And once again, it'll give you some options here where you can share or save. This only happens if you're logged in. You can give a private link and all that. And that permits other people to actually see your work, which is this plot, and also the data that it's based on.